Hello, my name is Timothy Mewa Joseph, and I welcome you to my Facebook page where I teach physics. In today's lesson, I'm going to teach you how to do the calculations in conservation of mechanical energy. So sit back, relax, and enjoy the lesson. This is the first question in which I'm going to use to explain to you how to do these calculations. The first question says, a 5 kilogram mass is dropped from a height of 30 meters above the ground. Determine the velocity of the mass when it is 80 meters above the ground. So to do this, we are going to draw the diagram to illustrate the information that we have in the question. So let's begin. So let's say this is our ground level here. I'm going to put the ground level here. And then the object was dropped from a height of 30 meters from here to here, for instance. So let's call this height A, which is 30 meters. So let's put the object somewhere here. The mass of the object is 5 kilograms, and it was dropped from the height of 30 meters to this. When it reaches the ground, it rebounces back, according to the question, to a height of 18 meters above the ground. So let's say this is height of 18 meters above the ground here. So this is the object. It rebounces to this height, which we are going to call 18 meters. 18 meters. So let's call this height B, which is 18 meters. And then the mass of the object, which is 5. This is velocity at which it bounces by here. So let's call it velocity V, which we are going to calculate VB. So let's call it VB. So VB, this is VB. Okay. Now, to do this calculation, we first of all calculate the energy processed at A. The energy processed at A, that is the potential energy processed at A. So let's write something like this. So at A, our potential energy is giving us this mgh. Therefore, we can calculate potential energy at A. So let's put A here, height A. So potential energy at A, which is the total energy as well, is equal to mass, which is 5 kilograms, times acceleration due to gravity. It is 10, so that value is constant, meter per second squared, multiplied by height at A, which is 30 meters. Then we can say that 5 times 10 is 50, and then 50 times 30, we should have 1,500. Yes, 1,500 joules, because we calculated her energy, potential energy at A. So that is the unit of energy. So now we have calculated the energy processed at A, which is also the total energy processed at A. So for us to calculate this velocity of the mass when it is 18 meters above the ground, we are going to say that the kinetic energy, the sum of the kinetic energy and that of the potential energy at B. Sum of the kinetic energy at B, and the sum of the kinetic energy at P equal to the potential energy, that is the total energy. So we are going to apply this equation, that is total energy at A, which we have already calculated. Total energy at A, we have calculated it to be 1,500 equal to sum of the kinetic energy at B and that of the potential energy at B. So we apply this formula, half times mv square. So let's call this one VB plus mghb, that is the new height after the bounce. So our total energy at A, which we have calculated to be 1,500, we write it here, 1,500 equal to 1/2 times the mass, which is still 5, then times, okay, so times this VB, so is the one we're looking for. So let's just say 5 VB square, 5 V square B plus mass times 10, then times the height at B, the new height, which is 18 meters now, 18 meters. So now we just express this. So I'm going to clean this space for us to get space to do the calculation. You've already seen the interpretation of the question. So this is very simple. So I need this space for more calculation. That is to complete the calculation. So here we have 1,500, 1,500, which is our total energy, equal to 1 times 5 V square, which is, we are going to have this, okay, divided by 2 plus 5 times 10 is 50, and 50 times 18, we should have 900, right? Yeah, this is correct, 900, yes. So here one, okay, maybe should I take LCM here? I should just use an element. Okay, let me just use the simple method, which is the LCM method. So the denominator is 2, so we are taking LCM. So let's simplify this now. So 2 into here, so this is just 1 times what we have as our numerator, so we have it back. So plus, this is going to be 1800. 2 divided by 1 is 2, and then times this. So we're having something like this. Therefore, we should have 1,500 equal to, here you can cross multiply. So let's just cross multiply. So this is over 1. So we cross multiply without wasting much time. So let's cross multiply. And then when we cross multiply, we should have 3,000. Yes, so we cross multiply that. This will multiply this by this. So we have 3,000, right? 3,000 equal to 5 V square plus 1,800. Okay, what is this dot doing here? I don't want to see you. I don't want to see you there. Okay, so, and then we collect like terms. So which means we are going to say 3,000 minus 1,800 equal to 5 V square. So we should have 3,000 minus 1,800. We should have 1,200 equal to this guy. Since we are looking for this, so we will just divide both sides by 5 now. So I need to erase this again, this page, so that we can have more space again to complete our calculation. Yes, so let's erase this, erase, erase, erase. Why do I feel like singing? I want to sing, but I'm having a lesson, so I can't just sing. Okay, maybe I'm going to dedicate another period for that. All right, so we say V square divided by 5, so we should have something like this. We say V equal to root, because of the square root, the square rather, 1,200 divided by 5. Oh, is somebody confused? Okay, let me just show the proper way. doing it so that I won't confuse anyone here. Okay. All right. So we see we are dividing both sides by 5, right? Okay. So we have 1,200 equal to 5v squared. So this, we divide this by 5, we divide this by 5, and then this goes. So dividing this by 5, what do we have? Should we have 240? Yeah, 240 equal to 5v squared. So, yeah. So now taking the square root of both sides, we can say that, what am I doing? Goodness. I'm not supposed to write this 5 again, sorry. Because it's just because I didn't cancel it here. So it's cancel, I kill you now. So you shouldn't be here again. So I've kept you since I forgot to kill you in the first place. So we have just 5, just v squared. So now let's take the square root of both sides. When we take the square root of both sides, we're going to have our v will be equal to root 240. And what is 240, please? What is the square root of 240? So the square root of 240 should be 15, because the square root of 225 is 15, right? So we should be having 15 point something. Where's calculator? Yeah, I got it. 15.5 meter per second. So this is the velocity of the mass when it is 80 meters above the ground. When it is 80 meters above the ground. So this is the velocity. It's 15.5 meters per second. So into one decimal place in some questions, maybe especially multiple questions, there's multiple choice questions where you have the options as answer. So here they can just approximate it to maybe 16. It is still the same thing. So okay, let's consider another problem. The second, so I'm going to erase the screen again. Let me get rid of everything that I have here. I clear it away and then take the second question. So this is the second question that I'm going to use to explain how to do the calculation and conservation of mechanical energy. I hope you learned a lot from the first question. You can watch the video as many times as you like for you to get the proper understanding. A 3 kilogram mass is dropped from a 12-meter height. At what height would the velocity be? 5 meters per second. So we are going to also interpret this question using diagram. So let me get my pen. This time around, I want to use green color. I love green. So I'm going to put the ground level here. So this is ground level, ground. So let's go back to our question. From a height of 12 meters, so let's see, this is the height here. So I want to put the height here. 12 meters from here to here. So let's call this height A again. I want to change letter. So let's just stick to this height A, which is 12 meters. So the object was dropped from here. So let's say this is the object and it travels through this part. Oh, it is bent. Why? Oh, it is bent. I don't like it. It's bent. Okay. So let me try to make it straight. And at what height would the velocity be? 5 meters per second. So let's say the object travels towards the ground and then I don't know the height. So we are going to calculate the height anyway. So this is the object. So the which is the mass is 2 kilogram. Okay, what again do we need to put? So they're asking us to calculate. Okay, the velocity here, velocity B is given as 5 meters per second. Okay, what again do we have? So they're asking for the new height in this question. So that is this height P. Height P. We don't know it. So we shall look for it. It's missing. Okay. Again, we are going to calculate the total energy processed at 12-meter height, which is going to be the kinetic energy. So let's say total energy processed at the height of 12-meter height. So it's going to be given as a potential energy, which is also given as mgh. So this is A here. So we calculate it first. So the mass is 2 times 10, g is 10, acceleration due to gravity, then times height. What is the height, please? The height at A, so it's 12. So let's multiply these guys together and see what we have. 2 times 10 is 20, and 20 times 12. We should have 240, right? 240 joules. Okay. Now we can now calculate the total energy at B by saying that for us to calculate the height, the new height here, we are going to say that total energy is equal to sum of the kinetic energy at B and that of the potential energy at B. So something like this. So at B, so let me write the equation. At B, we say that total energy, this potential energy, is equal to sum of the kinetic energy at B, mv square. So this is B plus and that of the potential energy at B as well. So something like this, and then we substitute our value into this guy. So we have already calculated total energy, which is 240 equal to 1/2. Should I use the other side? Times mass. What is the mass? How am I forgetting? 2, then times 5, because that's our velocity at B. So 5 squared plus 2 again. Mass, yes, 2. Yes, 2 times 10, then times height at B. So which we are looking for? This one we're looking for. So we're looking for this. Okay. So I'm going to erase these parts so that we can have space to complete the working. We have space to complete our working. Okay. So we have 240. 240. I want to say that this 2 will cancel these 2. Yes, let's not waste time. So we have just 5 square equal to 5 square, which is 25, then plus 2 times 10 is 20, 20 times HP. So we're going to have something like this, 20 HP. We're looking for this guy. So again, we collect our like times here. We collect like them. So we should have 240 minus 25 equal to 20 HP. So 240 minus 25. Should we have 215? Yes, we should have 215. Yeah, I don't need to press capital for this. My brain is active this evening. Yep. So we are looking for this guy. So we just divide both sides by 20. Therefore, we can see our new height will be 215. If I'm making sense, yes. 215 divided by 20. So when we do that, how many 20 do we have here? 200 and 200 and 210. Yes, remember 15, 15. Okay, so I know I'm going to have 10 points 8 meters. So this is our new height. Yeah, this is the new height. So with these two examples that I've given and explained to you, I hope you have learned how to tackle the calculations in conservation of mechanical energy. So thank you for taking your time to watch this video lesson. Please like the video, share it, and make comments. Let's be connected together. Let me know how you feel or what you feel about my lesson. So if you have any questions, write it in the comments box. I'm going to respond to your questions. So as I've said, please like and share this video and feel free to follow my page for more updates of my physics lesson. Goodbye.